Okay, so this is my attempt that I'm going to explain sort of teleport and also Farcaster hubs and kind of how they work. So if you watch this before the actual meeting, that would be pretty cool. And let's see, so open Farcaster dev chat, and we'll talk about teleport in the Farcaster hub. So I wanted to basically create this video as sort of like a precursor so we don't have to spend too much time in the actual meeting talking about this stuff. And we can just deal with questions or like how the code is structured basically for all of this. And Avi might have alternative things if I'm wrong about something, or if you want to add something I missed, feel free to do that. Cool. So basically, the way hubs in general work, we'll do a little bit of hub context and then we'll get into some teleport stuff. So, as you probably know, like the work that hubs do can be divided into two major categories. There's some on-chain stuff and there's some off-chain stuff. On-chain here would refer to like optimism, not ETH mainnet. And then there's some off-chain stuff that is going on. So in the on-chain stuff category, there's four things that are happening. So FC has four smart contracts on OP. These are the ID registry, the key registry, the storage registry, and then a to-do is the fname registry. So this isn't deployed yet, as far as I understand, but it is coming. So I'll just mention it anyway. So let's go over sort of like what these are used for. So the ID registry, first of all, the ID registry, the purpose is it contains a mapping from ETH addresses to your FIDs. So when you create a new account for the first time, the ID registry is what keep tracks of an ETH address to a FID, and this is done via the custody address that Warpcast creates for you. If you sign up using an alternative client like Flink, the reason Flink accounts don't work with Warpcast right now is Warpcast is kind of designed to deal with the custody address, whereas Flink obviously, creates the mapping in the ID registry from your normal ETH address. So that's why that doesn't work, by the way. But anyway, ID registry is basically a mapping from ETH address to FIDs, and it sort of is what proves, who the owner of a given FID is. You can call those smart contract functions yourself to register a new FID, and that's where you have to pay. So it uses like a chain link price feed to determine like ETH to USD conversion ratio, and then you can pay in ETH and get a new FID directly on chain. Or if you're using Warpcast or something, then you pay with your credit card and it does the on chain transaction for you. So that is what the ID registry is doing. For the key registry contains a mapping of FIDs to public keys. So effectively, when you create new session keys, which is, by the way, how all Farcaster clients work. So like Warpcast has a session key for you, which is the EDDSA key they talk about, and alternative clients like Supercast or Flink have a session key that they create. And when you sign in with Warpcast or something like that, basically, it creates a new session key and it links that on chain. So messages coming from that key are considered to be related to your FID, right? And um, and yeah, like just keep in mind, like the key registry only has the public keys, and like none of the messages are actually being posted on chain. It just contains the mapping from the public keys to the FIDs. For the storage registry number 3, this is again a mapping from FIDs to how many storage units you have. So we'll get more into storage units in a second, but storage units are basically like, for each storage unit, that you purchase, you get 5,000 messages, quote unquote, that you can post on Farcaster. Now, a message isn't always a cast because a reaction is also a message, like liking something, commenting on something. they're all also messages. So you need one storage unit gives you 5,000 messages that you can post, and then you can purchase more if you need to, however many you want. And yeah, like the storage registry basically keeps track of that. And there's on-chain functions again to like do the transaction to buy more storage units. The fname registry, it's not there yet, but this will be a mapping from FID to username, so on-chain username, so nobody can fake it. But we won't go too much into that. So this is kind of like the four main contracts that we need to take care of. And then there's some off-chain stuff that is happening. And on the off-chain side, basically what happens is the hubs have a libp2p based gossip network that runs, and they're basically gossiping and sharing messages back and forth with each other. There's many different types of messages, so there's many different types of messages, and you kind of need to handle all the different types. We can look at the Farcaster docs specifically and get an idea of the different messages that exist. So this is so let's say if we go to submit message, right? You'll see in submit message, I don't know if they have a full list over here. It might be in the Hubble documentation. It probably is in the Hubble documentation, but anyway, we'll get to that later. Yeah, we'll get to that later. But there's basically different types of messages, such as like creating a cast, creating a reaction, deleting a cast, things like that. Many different types of messages that are handled on this libp2p gossip network. And just to give you sort of a high level overview now of how everything sort of connects, we'll black box some information at this point, but what you can imagine is, let's say there's like this network of hubs over here, right? These are different hubs that are connected to each other in some way, shape, or form. Let's say something like this. And these hubs are what apps built on Farcaster are using to get information. So some app, let's say some Farcaster client, the client needs access to a hub. Well, there should be a bidirectional arrow. The client needs access to a hub to see stuff on the network, and then the client is also posting messages to the hub. Generally, for anything that requires any sort of data, though, like if you want to do some sort of analytics, like Searchcaster, for example, or like if you basically want data in like an easy to access form, hubs unfortunately aren't too great for that because of how they store data. I will black box that concept for now. I'll come back to it, but hubs aren't super great at retrieving historical data in like a good form that makes sense. So there is kind of an indexer in between. So you can kind of imagine, like Ethereum contracts, they emit logs and stuff. And this is an analogy, by the way, but like the logs are fine, but if you have to like sync logs every single time you needed access to something, that's kind of bad. So we use indexers like the graph or whatever. So it's kind of a similar concept where hubs have data, but the way the data is stored isn't the greatest for certain types of applications, particularly ones that require historical data, maybe to do analytics. So there is kind of like an indexer called the Postgres replicator. So this is open source, but what the Postgres replicator does is it basically takes data from the hub and it copies it over, as the name suggests, to like a PGDB that you provide. And this is a nicer schema. So the way the tables are stored in Postgres over here, this is a nice schema. And then clients, or let me say like apps, would oftentimes require the PGDB using the Postgres replicator instead of talking to a hub directly, because they might need like that sort of data. this is, again, this, I'm talking about this because this is actually like fairly important. We'll come back to why, but just know that, this exists. This is a thing. So when it comes to building a hub, when it comes to building a hub, you know, we need to handle both of these things, right? We need to handle on-chain events and we need to handle off-chain gossiping. So you can think of it kind of like, we're listening to events on these smart contracts, and let's say anytime a new FID is registered, this contract will emit some sort of event. So the hub is constantly listening to these events being emitted on chain, and it needs to respond to those events. So if it sees something like new FID got registered, it needs to update its local storage, update its local database, whatever, to reflect that. Otherwise, it won't be able to recognize messages from this FID, and so on and so forth. So it needs to be listening to events from all of these different contracts. The first time the hub starts, it syncs from the first block where these contracts were deployed. It syncs all the events from the first block where these contracts were deployed, and then in the future, it just sort of keeps listening to them in the background. And this is kind of a blocker. Like, you can't really do number 2 without doing number 1, because messages that are happening on the gossip network, like, none of them really make sense if your hub isn't aware of historical on-chain events that have already happened. So you need to solve for on-chain events handling first before moving on to off-chain gossiping. And then once we've done this, once we get to the gossiping point, this is basically like, we peer with the other hubs, we're sending information back and forth, and you can imagine, like, you get some sort of message. There's a message type called cast add, and this is what happens when you like post a new cast or like add a comment or something like that. So let's say you see a cast add message, some other hub sent it to you over the gossip network. You see the cast add message, you need to do, sorry about that. You see this, you need to do some validation, right? So you see this message, and then you need to do some validation. And this is not an exhaustive list by any means, but just for example's sake, you might need to do stuff like, you need to verify the signature of the, like, it claims to be like from FID number 1, let's say. So you need to make sure, you need to verify the signature to make sure it is coming from a key associated with FID 1, which means, by the way, you need to have the key registry events fully synced up to associate keys with FID number 1. So signature verification is an example of one of the things you need to do. You also need to do, like, for example, in the case of cast adds, you need to check the length of the cast, which is currently restricted to 320 bytes. You need to check for conflicts. For example, you might have already seen this message before and already processed it, but some other hub just sent it to you again, in which case, like, you just kind of ignore it. Otherwise, maybe you might know that in fact this cast was deleted, right? Because the order of messages isn't guaranteed. It's a peer-to-peer network. So one hub, you might have gotten the message from some different hub saying this cast has actually been deleted, and then you get the cast add message from a different hub. So you might know this was deleted, in which case, again, like, you don't really care about this too much. And you might have, like, the poster might have exceeded their storage limits with this cast, in which case you also need to do, like, stuff like delete their oldest message to make space for this. There's just some examples, not in order, but just to give you sort of an idea. So you need to do some validations, and assuming all of this goes well, then we gossip it further. we let other hubs know that we're connected to, that we saw this message, so that they can go do the same thing. With that in mind, this is still a little bit oversimplified, because there's a few things that are also happening. Gossiping isn't as simple as just passing messages around. There's a few other things that are happening. Number one, there is always the possibility, because it is a peer-to-peer network, and also your node can go down, your hub can go down, or maybe your RPC for on-chain events isn't responding properly for whatever reason. There's a variety of problems that can happen in a gossip network. So you can imagine, for example, you can have missed messages, right? Missed messages, maybe your hub went down for a little bit, or hubs that you are connected to went down for a little bit, or there were network issues, whatever. You missed some messages over there. So Hubble implements a diff sync protocol, and basically what happens is, you can request another hub and tell them that, hey, so basically, actually what's happening is every 5 minutes or so, you're talking to the hubs you're connected to and asking them for, hey, what is your latest message, right? And the way messages are stored is, you maintain a Merkle tree of messages in the node, and you're asking people, hey, what's your latest Merkle tree route, right? What's your latest, what's the latest messages you have? And then, they'll tell you that information. And if you find out basically that you're behind, or the other person finds out that they're behind, they can basically request, hey, look, I need to do a diff sync. And then we send over some information. We exchange some further information beyond the Merkle route, saying, okay, which one of us has missed messages? Is it me or is it you? And we figured that out, and whoever's behind, they can request, okay, look, are you willing to share all of that data with me? Because some nodes might not be willing to do that for whatever reason, because it can be somewhat bandwidth intensive and somewhat CPU intensive to do a diff sync. So depending on how the nodes are configured, some might reject your diff sync. They're not required to do it per se. So anyway, you request a diff sync, happy path, they say yes, okay, and then it creates a CRDT package, sends it over to you, you decode it, and you process them all. Important thing to note over here is how this data is stored and what is actually being sent over the wire. So Hubble stores all data in a CRDT format, right? So CRDT, I forget the full form of this, CRDT full form. It is, no. Conflict-free replicated data types, okay? So CRDT form, it basically, it allows you to, merge information very nicely. If you see, conflicting information, or, you're not sure, since order of messages isn't guaranteed, CRDT is a really nice way to sort of merge all that information together without conflicts. So all of the data is being stored in a CRDT compatible manner. And, during the diff sync, because it has CRDT, when we diff sync, it all sort of just works out. But importantly, Hubble, not a hub, but Hubble, which is the hub implementation that currently exists, uses RocksDB for storage. Now, RocksDB is good. If you aren't familiar with RocksDB, I wasn't familiar with RocksDB before we started doing teleport stuff, but RocksDB, it's basically an in-memory, well, not in-memory, it's a binary key value store developed at Facebook, and it's pretty efficient for writing, right? You can write data to RocksDB pretty fast, and it also takes up pretty little space because you're literally just writing raw binary blobs into it. And the fact that they use RocksDB for storage, by the way, is also the reason that, the whole Postgres replicator pathway of things even exists, because, you know, reading from RocksDB is kind of a pain. You can write to RocksDB very fast, but reading is a bit of a pain because you need to decode the binary stuff every single time. And, there's no like schemas. It's not like a SQL DB, obviously, there's no schemas. It's literally just a key value store. So if you want to get like large amounts of historical information, which a lot of apps need, um, RocksDB isn't really great for that, which is why you use the Postgres replicator, and which is also why partially the costs of running a hub are somewhat expensive. Depends on like what expensive is to you, of course, but because you have to pay for the hub, you have to pay for a Postgres instance, and you have to pay for like the replicator cron job that needs to run every now and then. So anyway, so use RocksDB for storage in Hubble. Teleport intentionally did not maintain compatibility over here. And the way Teleport is set up is we use SQLite. The reason is, SQLite has gotten 10 times better in the last couple of years. There's newfound interest in SQLite, and it is really, really good now. So we do take a little bit of a hit in terms of write performance, but reads are much better, right? So the P2P network, it's obviously writing regularly, but we imagine that as more and more apps get built over time, it is going to be fairly read heavy as well. And SQLite is fast enough and optimized enough. And now there's also like distributed SQLite databases and whatnot for like high scale applications. So we chose the decision to go with SQLite. We can skip the whole replicator process. We don't need any of that. And it just works nicely. There is some implications for doing this. So for the diff sync protocol, we can maintain compatibility because this is based on like the Merkle tree structure of messages that are stored. However, there's another thing later on that happens. Actually, this has implications for like how snapshot syncs work in hubs. I think I spoke about this a bit too early. I think we'll sorry about that. I'm freestyling, but I think I spoke about this slightly early. We'll get to snapshot syncs, but just keep this back of your mind. We don't use RocksDB, we use SQLite. I did want to mention another point about problems with the gossip network, or not problems, but I guess like things you need to think about in the gossip network. The other thing is like peer scoring. I should have mentioned this first. So we talked about missed messages. The other thing that can happen is basically the hubs you're connected to, there's a scoring protocol where basically, you're scoring the hubs you're connected to, and they're scoring you and other hubs they're connected to constantly based on, how quickly are you responding to requests? Are you sending fake information perhaps? Are you being malicious? Yada, yada, yada. And the score is basically, it's a number from 0 to 10. And there's a configurable threshold that you can set. I believe the default is 3. I might be wrong, but there's a configurable threshold. And basically, if a hub you're connected to, or your score from the perspective of a different hub, falls below that threshold number, they'll disconnect you, and you're supposed to disconnect them. And then go look for like a new hub to connect to. So just keep in mind, like, these are things that need to happen. And these two cases, like handling of these two cases, like asking a hub to start a diff sync with you, or doing scoring or checking and like connecting and disconnecting, these types of messages are also like messages on the libp2p layer, right? These are messages that are sort of it's not messages like on Farcaster, like there's like categories. So like adding a cast or deleting a cast, for example, is a very Farcaster specific thing, like things you see on apps that you use. Whereas scoring and diff syncs, etc., they are like slightly lower level, slightly under the hood types of messages that the gossip network is doing to keep everything nice and clean. Um, so yeah, like this is just kind of context on like the different types of messages that you might need to handle. Um, and yeah, I mentioned RocksDB SQLite choice, so we'll get to like snapshot syncs in just a second. So with this context, basically what we end up at is this is what is, by the way, bare minimum required for the protocol so far. Everything we've discussed so far is bare minimum following the Farcaster specification. You know, listening to on-chain events, handling off-chain gossip messages, diff syncs, peer scoring, yada yada yada. There's a couple more bare minimum stuff we need to do. So there's a gRPC API for clients, and then there's a gRPC API for admins. Both of these are also part of the specification, and these need to be implemented to have an MVP ready. There is a REST API in Hubble as well. I don't recall, I might be wrong, I don't think this is part of the standard, but there was talks about making it part of the standard, so maybe it is now. So whatever, but the REST API sort of was done because, you know, doing the gRPC calls from like a TypeScript app, especially like a front-end Next.js thing, it's kind of a pain in the ass where you need to set up relay and whatnot. So the REST API that Warpcast had and like Nanar has, part of that is like being converted to a standard and being implemented in hubs directly. So there's the REST API, there's gRPC APIs, and then I don't recall if this is part of the standard or not, but this definitely is. And then there's some stuff that is non-standard that Hubble still does. So they have some stuff around monitoring. So it has like a StatsD client. It's like compatible with Prometheus and Grafana. So you can have a nice little dashboard going. And then snapshot syncing. This is also not part of the standard, but you know, do it because it's faster. And this is where I want to get back to like the database conversation. So the way snapshot syncing works, as I said earlier, when a hub starts for the first time, you need to, you know, sync all of these events and, you know, process a bunch of different messages and catch up with other hubs on the network, which can take a decent amount of time, you know, because there's a lot of events to process, which can take a decent amount of time. So Hubble has snapshot syncs like any other node. You know, you can download a quote unquote trusted snapshot taken at some point in time that Merkle Manufactory puts out. And what that is, it's basically a RocksDB blob, right? They like take a snapshot of the RocksDB thing they have running and put it out, and you download it and then you process it, and you know, obviously it's much faster than syncing everything yourself. Because of our choice of SQLite over here, this is again something we are currently discussing, like if it is worth the effort of maintaining compatibility with Hubble on this. Because if you look at like the Ethereum ecosystem, different nodes don't share like snapshot sync capabilities. Like you can't have like a snapshot sync from Nethermind and use it on like Go Ethereum, right? So most likely we're not going to maintain compatibility, because maintaining compatibility would mean like, you know, having a RocksDB layer to process that blob of information and then taking that RocksDB layer, like processing everything as a RocksDB blob first and then translating all of that into our SQLite schemas. So we probably won't maintain compatibility. It's the effort doesn't seem worth the return. We'll probably have our own format for snapshot syncs that is designed for teleport. This is currently a to-do, but yeah. So with that said, where teleport currently is we have the infra set up to, you know, sync up all the on-chain events. We have a SQLite schema that most of it is stored. There are a couple little bugs in there, a couple little to-do items, but most of on-chain events handling is done. For the off-chain gossiping, we have a lot of the foundational work taken care of. So there is a libp2p network that is configured. It can connect to other hubs on the network. The other hubs will kick us eventually. Like the connections don't last too long because we get scored really poorly because we don't handle a lot of the different types of messages that we need to. So we end up getting kicked pretty quickly, but it can connect to a hub. And in the past, I've shown on my Warpcast profile, like being able to share messages and broadcast messages to Farcaster through teleport, where like we'd connect to a hub and we'd send them a cast add message and it would process and it would appear. So there's some foundational stuff where the libp2p network is set up, it can connect, and a lot of like the libp2p level stuff that needs to be handled is being handled. The biggest to-dos over there are obviously there's like 10 to 15 messages or something that we need to handle and process properly and respond to other hubs properly that are all to-dos. So the way teleport was started is I started on the libp2p layer first, and set up that foundation. And then after that foundation, we actually moved on to doing the on-chain events handling stuff. And now we're sort of coming back from the on-chain events handling stuff back to the gossip network and going to start writing code to handle the libp2p messaging things over there. So that is where we're currently at. This a freestyle overview, so sorry if I blabbered on too long, but hopefully this helps. And yeah, we're meeting later, so we can just talk about any questions or anything over there. Cool. All right.